Well, good morning. This is another day here in the Twisted Knot Wood Shop. Today's February 28th, 2016, and yesterday I spent a bit of time organizing and straightening up around the lathe corner, and in the process of doing that, I discovered that there were some things that were, hanging all over the place, different parts and on a shelf here and hanging up there, and in particular, these gauge blocks that I use for turning dowels or tenons, and they're all different sizes and different materials, and not that I'm compulsive or anything, but I thought it'd be nicer if they were all the same size, same material, and I could have better control in containing them in that box there. Now, you've seen in my previous videos where I've used these gauge blocks for turning dowels or tenons, and the reason for that is because some asshole in the past has decided you can no longer get a 1 7/8 dowel or 1 inch dowel. It's a 16th under or some goofy thing like that, and but since all drill bits are 1 3/4 inch, say, and you drill a hole, well, then you expect to have a dowel or a tenon that size. Now, what I do is I hold the gauge block up whatever I'm turning, and when that shadow line closes up on that radius, then I know I've got that radius. A person could use calipers. In this case, I've got 2 different types here. The problem with the one on there is the jaws on it aren't long enough to go on a wider diameter, say a 2 1/8, whereas that one will. But the problem is adjusting the width there exactly, because if you already got the hole drilled and you have this and you use that as your gauge, well, chances are it's either going to get too small or it's going to be too big and you're back at the lathe again, cutting it down. And I mean, you could set it, but the accuracy of it is, limited. Excuse me. So what I'm going to do is make all the blocks the same size, and I've got a plate here with a harness there to hold this material, which is MDF, and it's going to end up being 3 5/8 square, and that it's cut long. That line there would be what it'll be at 3 5/8, but the reason it's cut long is so I could develop that center point there. And since I'm using Forstner bits, I'll set that hole underneath on the drill press table, mount the plate permanently to the auxiliary table, and then this point would allow me to register into that hole so that I can secure the plate. Now, after I drill this block, I can cut that off and I'll have exactly 1/2 diameter of the drill bit. Now, if I hold my mouth just right and the larger diameter, say, I can probably get 2, one there, and then say 2 inch on the other side, and that would be nice, and I'm certain I can do that. But the problem is that when you get the smaller diameters, it's not that I have a problem with it. It's just that with these smaller ones, anything less than 5/8, I found it's kind of hard to use that gauge block on turning tenons and dowels. So that's where this guy would come in, and then I can get that pretty darn accurate. But I'm going to try it and use the smaller diameters than 5/8, and maybe even go down to 1/4. I don't know, we'll see. But if I can do that, then I can get 4 of them around the corner there, or around the edges. So I got the material milled out, 3 5/8. This is just a piece of MDF scrap that I had. And over here at the table saw, I've got a standoff block clamped to the fence, and from here to the blade is 3 5/8. But what allows me to do is, if I bump that up to the standoff, I can slide it through, and as I make the cut, then this resulting block won't get wedged, since it's so narrow, won't get wedged. And this saw is accurately tuned. I have no fear of it, but it's a lot easier doing it this way than, maybe you slip or move your hand or something and it get bound up, and the next thing you know, you got a horrific kickback. So I'm going to set the block, the table, the plate on the drill press and drill the very first one, and I'll pick that up in just a second. All right, here I am at the drill press, and the first step is that block I showed you that was cut wild. I got to make sure that the center point of the drill bit is in that hole, and then I can fasten the base plate to the tabletop. And this is another good reason, incidentally, that anybody that has a drill press, you should make yourself an auxiliary table. Everybody knows that the steel table down there has little slots in it and little things that you can clamp stuff to, but it really makes it inconvenient because you got to go through all those extra hoops and jumps and everything, and to clamp it down, where a simple brad or a screw, depending on whichever you want to use, is a lot easier. And yes, eventually the tabletop will get, like those little holes there as the tabletop is turned, the drill bit, radius is around and it gets holes, but it's not an issue for me. And yeah, it does get stained up with this oil and stuff when I'm doing metal. But if you have a drill press, you ought to think about having an auxiliary table. Now, because I use it all the time for all kinds of different things. So the first thing is to make sure that the point of that drill bit is into that little hole, and then I can brad nail it down. I think I felt it move. Nope. All right. Now I've got the table height locked. There's a little lever down there in an earlier video. You've seen how I did that. Or if you go back and look. And I've got it set the height so that when I remove the block, I can loosen the chuck and the bit will come out. I can put in the new bit or the next bit, and I don't have to continually up and down the table to change the bits out. So right now I'm going to cut this wild block, and right after I got some other blocks cut ready to go, and change the bit out, and then we'll test my theory on whether or not the Forstner bit will cut without the guide hole. Okay, that one was 2 1/8. See if I'm seeing the same thing you are. That one's 2 1/8, but by the time I cut this off, I'll have half that circle. That was the reason for having it long, besides having that starting hole point. And the next block, I'm going to go the next 2 steps down because I want this one 2 1/8 and this one 2 inches. So I'll go down to 1 7/8. Okay. Remember, there's 3 holes in the chuck for a reason. Use every one of them. Okay, so remember I showed you that standoff block at the table saw, and so I've got it cut. If I turn it over, it should fit in there, and it does. So that setup is good. So here's where the theory gets tested. So there is 1 7/8, exactly 1/2 of a hole, so the jig works. And now I just keep stepping down. So this was 1 7/8. This one will be 1 5/8 down here, and I'll just move along, and I'll pick this up when I get further along. All right, I'm back, and as you can see, all of the blocks have been drilled out, and as each one was drilled, I marked the dimension on it, or the diameter, excuse me, and the larger diameters I was able to get 2 out of a single block, and then as I got down to the smaller ones, I was able to get 3. And you're probably wondering, why did I not have a 4th one? Well, I could have done so, but the other one would have only ended up with 2 because I didn't get any smaller than a 1/2 inch, because as I said, I could use this type of caliper, which is more accurate than this guy as described earlier, because of being able to set that distance in there accurately. But I can set this one accurately based just by putting these jaws around say a drill bit, and then I know I'm at a 1/2 inch, and lock it down, and sorry, I had another tool there, lock it down, and then it'll slip on and off, or as I get close to that diameter on the lathe, it'll slip on and I know to quit. So I'm comfortable with this, but there's no sense in getting anything less than a 1/2 inch. Actually, I shouldn't even have done the 1/2, but since the other one, that one over there, was 3 diameters cut in it, I just made it uniform over there. And the second reason is, when it goes into the box, see which way is the best way to show that. Maybe that. When it goes into the box, if I put them in there like that, I have a flat spot on top that I can write the diameters, in this case 2 of them, so it would be written here 2 1/8 and 2 inches, so that when I pull the block out, I know that that's the one I got in my hand. And I think that'll look a lot better with them all stacked in there like that. And just pretend that you see writing on there. And out of what, 1 2 3 4 5 6, I was able to get 3 5 7 9 10 11 12 14 different diameters out of those little blocks. So I think that's going to work out pretty nice. And what I'm going to do with the rest of the space after those blocks are in that box, I have no idea. But anyway, I just thought I would share that with you. And if you have a lathe, you owe it to yourself to make some gauge blocks like that, and it'll make life a whole lot easier for you. Well, I thank you for watching, and we'll pick up another video down the road. Take care.